In this video, I'm going to go over convex mirror image formation problem. My name is Ryan. So this problem says an object is placed 25 centimeters in front of a convex mirror with a radius of curvature of 30 centimeters. Where is the image located? So we're trying to find the location, how far either in front of the mirror is it, or how far behind the mirror. These two options are behind and these two are in front. So basically, let's first ask ourselves, what do we know? So it has this saying here that the radius of curvature is 30 centimeters. We can automatically say that if our radius of curvature is 30 centimeters, our focus is going to be 15 centimeters. Because if we have a circle, sorry, that's pretty terribly drawn circle, but it'll get the point. The radius will basically be 30, and the focus is always halfway between the radius and the center of the circle. So it would be approximately right here. So basically, we can say F is equal to 15. It also says a convex mirror. So we know a convex mirror will look something like that. It's placed in front of that mirror, so we'll have an object kind of like that. We'll draw it up in the next slide what the diagram looks like. And so we're trying to find where's the image located. So we drew that F is equal to 15. So basically the big thing from this slide is that R over 2 is equal to the focus point. So let's sketch an image. I'll just write down our F is equal to 15 centimeters before, just so we remember that. So we have this circle. I'll draw the principal axes. I'll just put it here. And then this arrow will represent, the object. So this arrow is 25 centimeters away. And basically, this top point will shine a light. It'll go, this is supposed to be a straight line, but it will go here. And then if you think a mirror will reflect away, it has this, if we look at like the normal point, it'll try to reflect away now. It wants to reflect away since it's curved. Basically, we know with the convex mirrors, we have the focus point here, and it reflects away from that point. So basically, we can just draw, this goes out like that, and it will, it'll look something like that. I believe this focus point should be a little farther back, but I think the drawing does a pretty good job. And then we'll draw one more point so we can get an idea of where the object will be. One more point we can draw is across like this. And like that, because we know this angle theta is going to be equal to this angle theta, because the exact center of the circle is essentially just like, you can kind of think of it as just a straight line, and with a straight line it just bounces off. With the angle of incidence will be the same as the angle of reflection. You can think of it like that, and you can also think of it like these angles right here will also be the same. And then this will form not a real image, kind of like a fake image, and it will form it here. It'll form it behind, because we can see where these the two lines essentially converge. So those two lines essentially converge behind the mirror, making this image that forms right there. So from that, we can essentially just say these two answers are wrong, because those both say in front of the mirror, which we now know it's going to be a real image, a fake image, but it's going to be behind. It's going to be behind the mirror. So we can say we can break it down. It's either A or B now. So let's go on. So let's finish this up and solve the problem. Basically, one other thing we know, the AP equation sheet tells us 1 of SI plus 1 over SO is equal to 1 over F. So 1 over SI is just the distance of the image from the point that we were talking about in our image we previously drew up, and then the SO is the length of the object, and the F is the focal distance. So basically, the important thing for this formula is we get our units, our negatives and positives correct. So the correct way to do this is, what way is the light going? And we can see the light is going this way. So that means the positive has to be over here, and the negative has to be over here. So if we look, we can say, hey, the focal point is in the positive direction, since our focal point is right there. So we can say our focal point is positive. We go on to this, hey, the focal point is positive, so we'll say 1 over 15 is equal to 1 over SI plus 1 over, what's SO? Is SO positive or negative? Let's check. The object is right here. We can see that it's in the negative quadrant since we have these negatives here. So basically we can go back. We can say, hey, it's negative 25 centimeters, and we can put in negative 25. Negative 25. And then we could just add 1 over 25 to both sides. We get 1 over SI is equal to 1 over 15 plus 1 over 25. If we find a common denominator, we actually find out it to be 75. 75, 15 goes into 75 5 times, 5 over 75. 25 goes into 75 3 times, so 3 over 75. If we add those up, we get 8 over 75, and then we just have to flip it to get SI, and we get 75 over 8. Now we're between these two options. We just have to plug 75 over 8 into our calculator. Let's do that real quick. 75 divided by 8 is equal to, it's exactly equal to 9.375, and if we round it, it's approximately equal to 9.38, which is option A. And that is the answer. Thank you for watching.